objects as they got close to the camera appeared very fuzzy and became out of focus, and some disappearing altogether, doesn't seem to really hold up here, because video cameras don't actually work the same way optical cameras do. A regular 35mm camera, as you're focused on a distant object, as objects come close to the camera, they get very fuzzy. In fact, they can disappear altogether. But it's not the case with video cameras that have CCD imaging chips inside of them that actually process the images in a very different way than 35mm cameras do. We have to assume, and from studies I've made into the video cameras used on the space shuttle, that they're very high-tech, very high-quality cameras. Many of them are off-the-shelf cameras, but they're retrofitted with more advanced chips inside of them, and also image intensifiers and special filters. So the camera that we just did the test on was a very high-tech camera, but certainly you can imagine that what they're using on the space shuttle is even better. So why, in this scene that we just did, do a pair of keys appear so crisp and so sharp and in focus at the same time we're focused on a very, very distant object? It seems to defy the explanations and reasoning Dr. Knuth gave as to what we were seeing on the tape. James Oberg came up with excuses about what we were seeing. He couldn't acknowledge that the objects were going behind the tether. He just ignored the facts, the simple facts. He tried to say that what we were seeing was an optical illusion produced by the CCD in the video camera. He's trying to say that as these objects came near to the camera and they got close, they produced this fuzzy orb called an airy disk. When an object gets too close to a video camera or to a lens in a 35mm camera, for example, it just basically produces a very fuzzy and very soft light. It's very translucent and in some cases barely even detectable. They basically look like this. Sometimes they have a little black hole in the middle, just like our alleged UFOs do, and you get a very fuzzy kind of cloudy light around them. But all of the light is out of focus. So I can understand how he could make an assumption like that. But also with an airy disk phenomena, you would also never get a clear, very distinct line. When we see the UFOs going behind the tether, the line and the crispness on the line on the tether is so straight and so perfect, suggesting again that everything is in focus. When I demonstrated the test on the camera earlier, where we passed a set of keys very close, within 4 or 5 inches of the camera, while the camera was focused at an object far in the distance, we noticed that the keys were very much in focus. There was no airy disk around the keys. We didn't get an effect like this. We had keys that were perfectly in focus while the tree in the background was also in focus. So what was James Oberg trying to tell me? In the year 2000, I did a lot of investigations with different scientists all over the world. I got contacted by an astronomer, actually the head astronomer of the Canberra Observatory in Australia, Claire Williams. She had already seen the tether footage. She had already seen the STS-75 tether footage. She didn't have a very good copy of it, and we got into a furious debate about airy disks. She felt that what we were seeing on the tape in the tether were just airy disks. Airy disks are when you have like a star or a pinpoint light source, and the camera lens goes way out of focus. It produces something very similar to the UFOs that we've seen on the tape. You see a very soft black hole in the middle and a very translucent disk around the pinpoint light source. So what happens is the light becomes so diffused in the lens because it's so out of focus that we get this phenomena called airy disks. And when many people would look at this, they would say, oh, that looks a lot like the UFOs we've seen on the tape. And I understand how Claire Williams came to these conclusions. But there's no way that an airy disk could appear to pass behind. And remember, in the tether incident, we had the tether, which is over 77 to 100 miles away, and we saw the disk going behind it. They were not going in front of it. Once a camera lens is completely out of focus on a light source, all the light is out of focus. So you would have there's no way you would get a sharp line on the tether and then you'd get an airy disk separate from it. And if the two fused together, you would just get a lot of blurry light. When we did the test earlier with the video camera similar to the quality they're using on the space shuttle, in fact the cameras on the space shuttle are much better quality than the camera we did this test on, we held a pair of keys only 4 or 5 inches in front of the camera while the camera was focused on a tree 100 or 200 feet away. both were in perfect focus. That's because the depth of field of the actual camera, if this is the camera here, the video camera here, and the light is coming into it, what is known as depth of field is when a lens focuses on an object. Say we focus on this CD right here, this compact disc right here. Basically, once we're in focus on this object on a regular camera, from that point on, you have something called depth of field. Meaning, if you focus on this point, as objects get further and further behind it, depending on the aperture of the lens of the camera, a smaller aperture gives you greater depth of field. Objects start to fall out of focus as they get further and further away. The same thing happens when you're focused with a regular camera on something far away, like the tether. The tether was 77 miles away and drifting into 100, and then something came close to the camera, very close. It would actually just appear as a very soft blur of lights, which is what an airy disk is. Depending on how bright the object was, you might get a little bit of a brighter disk. But again, these disks, and you'll see some footage of them from the space shuttle of what real airy disks look like, they're very distorted, very, very out of focus. You don't get details when a camera goes that far out of focus. Now, the video camera is very different than a normal camera. The video camera doesn't have a film plane. It has sensors called CCDs. The CCDs in modern video cameras, such as those used on the space shuttle in the 1990s, are very similar to the cameras that we did the test on, with the pair of keys and the tree in the background. With CCDs, as objects come close to the lens, while the camera is focused on a distant object, you get phenomenal depth of field, meaning the object coming close to the camera, in this case the keys were only 4 inches away from the camera, were perfectly in focus. At the same time, the tree was also in focus. So you could not possibly get an airy disk with a camera like this. You have to turn all of the camera's light out of focus to get an airy disk. And in this case, we know the tether was in focus, and therefore anything coming near the camera should produce a very crisp image. So Clara Williams' theory in regards to airy disks didn't make sense to me.
Across the Atlantic Ocean over Africa.
The image we are seeing now shows what are true airy disks. This happens because the light reflecting off of a number of very bright objects is totally out of focus. The shuttle's cameras here are way out of focus, so we notice that we cannot make any distinctions about what we are seeing with clear features. But if we watch very closely, we can see that the space shuttle's video camera is going further and further out of focus very quickly, precisely as a large, brightly glowing object, which is pulsing, traveling on a 45-degree plane from left to top right and out of frame. Could the camera operator have intentionally moved the camera out of focus to avoid capturing this unidentified flying object as it flew by at close range to the shuttle during a live NASA broadcast? We can barely identify this amazing object so similar to the disc-shaped UFOs seen during the tether incident. In the test demonstrated, the only case this can happen using the shuttle's video cameras is when the camera lens is put far out of focus. When the video camera lens is in focus on a distant object, such as the tethered satellite 77 to 100 miles away, objects coming near the camera lens do not go out of focus. Therefore, they simply cannot produce airy disks. Also, more precisely, an airy disk cannot appear to pass behind an object 77 to 100 miles away, such as the tethered satellite, or any distance away, because they only appear when the lens is far out of focus. And when the lens is out of focus, we cannot make any distinctions about what we are seeing. Also, when you consider the number of things that look like this, in this case we have a CD, a compact disc, we all know what these are now. They look very similar, but they're not the same thing. A tire also has a hole in the middle, and it's wheel-shaped. UFOs are classically disc-shaped. This is what they normally look like. So because things look similar, we can't make the mistake of assuming that they're all the same thing because they look like they're the same thing. So anyway, in this debate, Clara Williams absolutely would not concede that what we were seeing were UFOs. But she did admit to me that she's mystified by this subject because she herself has actually seen UFOs.
A new scientific truth
does not triumph by convincing its opponents and